Hello, welcome to Algebra. Here we're going to learn the third and final type of solution technique for solving systems of equations that we're going to learn right now, and that's called solving systems of equations by addition. You might also see it in some other books as solving systems by subtraction, but by now you should know that addition and subtraction are really closely related, so it's the same exact thing. If you see subtraction, solving by subtraction in your book, it's the same thing as what we're going to learn right now. Now, there's just a few times every now and then I get to a topic that I'm actually really excited to teach. I'm really excited to teach you this topic because whenever I was younger and I first learned solving systems by addition, I was really confused. Because what I'm going to teach you here in a second is that you can have these two equations that we've been solving and you can add them together. And then that helps you solve it. But I was never taught exactly why I can just add, why can't you just add equations together? I mean, equations are something that you're supposed to be able to solve for the variable, right? Like move x here, move y there, and get the answer or whatever. But then you get to this technique, and then at least my teacher, she said, oh, you line the equations up and you just add them together. And then that helps you solve it. And I was just like, okay, I'll do it, but I have no idea why that works and why that's legal. We're going to fix that. You're going to understand how to solve by addition. You're also going to know why it's okay to do that and why and what's happening here. So let's tackle that first part in this lesson here. Let's say you have a system of equations. The system is the following. X plus y is equal to 3. And then we have the other equation is negative x plus y is equal to negative 4. Now typically when I do, in the past lessons, when I do solving these systems by substitution, I'll have one equation here and I'll write the other equation on the right hand side. That's because you're solving and you're plugging in and you're solving and you're plugging in, and it's easier in substitution to have them written side by side, far apart. So you can have them separate, you can do the substitution and it makes a little more sense. But here when you're solving by addition, what I want you to do is I want you to write it like I've done here. One on top of the other, and I want you to write it where the x variables are on top and the y variables are on top. So if your equation is given to you all jumbled around, move it around so that your x terms are here and then your y terms are here and then your numbers are on the right hand side, which is what we call standard form, remember? And then write the other one in standard form and line them up. The reason you're going to line them up is because in a minute we're going to add them. So having the x's on top and the y's on top is going to be very, very helpful. All right, so what I want to do is explain how this works by showing you how it works. So I'm going to tell you, remember, for an equation, any equation, you can do anything you want to that equation as long as you do it to both sides of the equal sign, right? So let's just take a look at the bottom equation here. I can add to this bottom equation here. I can add 5 to the left-hand side. No problem, as long as I also add 5 to the right-hand side. Okay, you agree with me so far. I can take this left-hand side, divide it by 69 or 72, as long as I also divide the right-hand side by 69. Right? Later on we'll talk about square roots. I can take the square root of the left-hand side, no problem, as long as I take the square root of the right-hand side. I can go on and on and on. Right? But let me ask you this. You probably hadn't considered it, but can I add, or I should say you have probably considered this. What if I want to add, y to the left, just the variable y? I can do that. I can add y over here, no problem. But in order to keep the equation correct, I have to also add y to the right-hand side. Right? So the reason I'm bringing all this stuff up is because I'm going to add the quantity x plus y to bottom equation. Now, before we explain why, I need to get through at least one cycle. I told you when I learned this stuff, my teacher never explained to me why we're doing it. I promise you I am going to tell you that. But I need to get through one cycle of it for you to see by example why it works, and then we'll explain in more detail. So this equation, this bottom equation here, is the following. It is negative x plus y. Right? Now I'm going to wrap it in parentheses just to kind of keep it straight, but on the right-hand side, it's going to be negative 4, right? And why not? We'll wrap that in parentheses too. It's just to kind of remind you that this comes from the equation, this comes from the equation. This is the term that comes from this is the term that comes from here. So you would agree this is exactly what I have written here. Now what I'm going to do is I'm going to add something to it. I'm going to add x plus y. I'm going to put it in parentheses, just to remind you that this is what I'm adding. So it's perfectly fine to add x plus y here, just like I can add anything I want, but I also have to add it to the right-hand side. Now let me give you a little bit of a hint. The reason why I'm adding this instead of just something else random is because x plus y is actually in my other equation. So just keep it in your back pocket for right now, right? I'm adding x plus y because, not just because I pulled it out of thin air, I added it because it's actually in my other equation. But in any case, you see how adding this to both sides has changed nothing. This equation with this term added and this term added is exactly the same equation. It's just like 1/2, the fraction, is equal to 50/100ths, is the same fraction. They look different, but they're the same. This equation with these terms added to both sides is completely balanced, and it's exactly the same as it is for the very first time I wrote it down here, right? So let's see what happens. Let's just kind of go through it and figure it out. What I'm gonna have, let me remove all the parentheses. I only put the parentheses there so that you can see it a little bit better. All right, now what I'm going to do next is I'm going to keep all of the parentheses in place on the left-hand side. Negative x plus y plus x plus y have changed nothing. On the right-hand side is negative 4 plus. Now, x plus y is here, that's true, but if I go up to my equation, I see that x plus y is actually equal to 3. So I'm going to substitute in the fact that I know what this is equal to. It's equal to 3. Now, it actually looks like this equation is quite different than what I started with, but it's the same thing. Nothing has changed. This equation is the same as this one. It just looks different. Just like fractions can look different a lot of times. You know, you can have 1/2, and that's exactly the same fraction as, you know, 100 over 200, or 1,000 over 2,000. It's the same thing as 1/2. We all know this, but they just look a little bit different. All I did was add x plus y to both sides, but then I just now know what this is equal to. It's equal to 3, so I can substitute it into the right-hand side. So then what I'm going to have, I'm going to strip away all the parentheses, and I'm going to have negative x plus y plus x plus y. All I did was write all this stuff down. I haven't changed anything. Equals, over here I'm going to go ahead and do the addition. Negative 4 plus 3 is negative 1, right? So then look what happens. On the left-hand side, I'm combining like terms, x and negative x. When I take x and I add it to negative x, it actually disappears. And when I have the remaining terms, which are just y terms, y plus y is just going to be 2y, and it's going to be equal to negative 1. So I can solve for y and say that y is equal to negative 1/2, just dividing by the 2 here. Now you see what happens. The magic really has already happened here. Because if you remember back to substitution, what happens? We did the substitution method. We do a lot of work and we get down and we solve for one of those two variables, x or y. Then we take that answer and we substitute it back into one of the original equations to find the other one. Here we have gotten down to the halfway mark where we now know what y is equal to, and then we can take and substitute it into any of these original equations to find out what x is equal to. All right? So what I'm going to do is I'm going to take this and substitute it into the equation. I'll just go ahead and do it probably over here. This first equation, x plus y is 3. It doesn't matter which one you use. I'm going to say x plus y is equal to 3, but now I know that y is 1/2. So it's x plus a negative 1/2 for y equals 3. So if I'm going to get x by itself, I need to add 1/2. So x is going to be equal to 3 plus 1/2. But to make it easier, I'll say that this is equal to 3 over 1 plus 1/2. And to get a common denominator, I will multiply this by 2 and this by 2, so I'll have 2 on the bottom. So then what I will have for x is going to be 3 times 2 is 6/2, and then over here 1/2, which will equal what? 7/2. You just add the tops, keep the bottom, so you have 7/2. So the answer to this system of equations is x comma y, so 7/2 comma negative 1/2. This is a solution. Now, if you're looking at this, and if you already know a little bit about addition, solving systems of equations by addition, you might think, this guy is teaching it totally different than what I learned in school, okay? And so this doesn't make a lot of sense. Let me show you, this is kind of like, I want to leave this on the board because I'm going to come back and explain why it's important to you, right? I don't want to go through it again right now. What I want to do is I want to rewrite the system of equations on the right-hand side, and I'm going to show you how you're traditionally taught to solve these systems of equations, kind of without the background. And then we're going to come back here and you're going to understand why it works from what I've already explained to you. All right? So the system of equation, the original system of equations is like this. X plus y is equal to 3. That's the first equation. The bottom equation is negative x plus y is equal to negative 4. Now what you're going to be taught in your class is the following. They're going to tell you, hey, you have two systems of equations. You need to have the x terms on top of the x terms, the y terms on top of the y terms, and the numbers on top of the numbers. And what you want to do is you want to add these things together, right? So when you add them together, hey, look at this. I'm going to add the x's together. X plus negative x, that's 0, so that just disappears. Y plus y is going to give you 2y. And on the right-hand side, 3 plus negative 4 is going to give you negative 1. And you're going to say, oh, I've already eliminated x. So then y is going to be equal to, divide by 2, you get negative 1/2. And you get the same thing we got down there with a lot less work. So what you're taught in your class originally, or in your books, most books, are basically just going to tell you, line the equations up, add them together, but you have to make sure one of these variables cancels. So in this case, I chose the system of equations very, very carefully so that you didn't have to do anything. The x variables would always cancel, right? So you have to have one of these variables cancel, otherwise you will never be able to solve for anything. In this case, I chose the equation so that when you add them together, the x terms cancel, right? But still, you can follow that, and that's how we're going to solve all of these equations going forward. But the thing that should bother you about this is if I don't explain what you're doing, you don't know why you can do that. Why can't I just add these equations together? Wouldn't that make another equation that's totally different than the first two? Well, the answer is yes. You have to have a reason why everything is okay to be done in algebra, right? The reason why you can add the left-hand side and cancel the variables and then also add the right-hand side is because of what I've done over here. Really what it boils down to is I can add anything I want to both sides of an equal sign. So if I start with this equation and I add the left-hand side of the equation too, notice all I'm doing here is adding the left-hand side. I'm doing this vertical addition, which is what I'm telling you that you're basically going to be taught to do. You're adding the left-hand sides, right? So I'm adding that. But in order for that to be legal, I must do it to the other side. That's the part they kind of hide from you in most textbooks. You're adding this to the left, but you're adding it to the right. But since you're adding this to both sides, and you know it's equal to 3, then you're really adding 3 to the right-hand side. So you see what I'm doing in this line, this purple line here, is exactly what I wrote on the board. I'm taking my equation, I'm adding the left-hand side of this equation, and I'm adding the right-hand side over here of on the other side of the equal sign. Just like over here, I'm adding vertically on the left-hand side, canceling out the x's. On the right-hand side, I'm adding vertically here. So I'm adding all of this stuff on the left-hand side, I'm canceling the x's, and on the right-hand side, I'm adding up the numbers. But the reason why you can do that is because really what you're doing is you're adding the same thing to both sides. That's why it's okay to do. You're adding the same thing to both sides. It's just on the left-hand side, I'm adding the left part of this equation, but I know that that's equal to 3. So when I add it to the right-hand side, I'm adding the same thing, x plus y, but I just know it's equal to 3. I'm adding that to the right-hand side. And since you have a cancellation in values of x when you do that, that allows you to solve for y. So the bottom line is, the reason solving systems of equation by addition works is because you can add anything you want to both sides of an equation. So if I take one of my equations and I add the left-hand side of the other equation to it, then on the other side of the equal sign I have to add the same thing, but instead of adding this version, I'll just add the 3 because they're equal on the other side. That is going to allow me to solve the system of equations only if I get a cancellation in terms like this. So here's the thing. We're going to go down and we're going to solve a lot of problems. We're not going to do this anymore. This was just so you understand why you're able to do it. What we're going to do is we're going to line our equations up, we're going to add them vertically, and then we have to have a cancellation in a variable. X plus minus x, that goes away. That's the only way you can do anything, right? If we don't have a cancellation in our variable, then we might have to make some changes to our solution, right? But we're going to do that. We're going to add them up, left-hand side, right-hand side, we're going to solve, and that's going to give us the answers to our problem. So in order to make progress, I think what I want to do is, yeah, I think I can do it right under here. Let me go ahead and solve the next system of equations under here. Let's go ahead and take the next system of equations for our next problem. Let's say we have negative 4x plus y equals 0. And then we have x plus y is equal to 10. So I want to solve this system of equations. So what you do is you write it in standard form. So here you have something x plus something y number, something x plus something y number. They're vertical. Now we can add these together. Absolutely, just like we did it. We can add the x terms together, the y terms together, and the right-hand side. Because of everything we've said, why it works, we can do that. The problem is, in this case, if we add this to this, the x's will not cancel like they did up here, because you'll have -4 plus 1. That'll give you -3. It's not going to cancel anything. The y plus y is not going to cancel either, because it's going to give you 2 times y. See, I chose this problem exactly perfectly so that these would automatically go away, but here they're not going to automatically go away. So what you have to do is you have to modify one of the equations to make it work. So what I want to do is, this is the original problem statement. Let me kind of do a little line under it. And I want to rewrite the problem directly underneath it. I want to rewrite the problem directly underneath it. Let's say that I have, let me write -4x plus y equals 0. And I write the other equation, x plus y is equal to 10. What if I multiply this equation? There's lots of ways to go about doing it. What if I multiply this equation, the whole thing, left and the right-hand side, by -1? What will that do? You need to think ahead of time what it's going to do. Well, it's going to change this into a positive 4x. And if I do this, it's going to change it into a negative y. Negative y is opposite of positive y, so then if I add them like that, it's going to work out fine. Why am I allowed to multiply by a -1? Because I can multiply equations by anything I want as long as I do it to both sides. So when I multiply this equation by -1, I haven't changed the equation. It's still the same equation. It just looks slightly different with different coefficients, right? So what I have here is I'm going to have, let me change colors. -1 times -4x is positive 4x. -1 times y is -y. -1 times 0, you got to do it to both sides, is equal to still 0. This one I haven't done anything to, so I'm just going to carry it down. X plus y is 10. And then I'm going to put a plus sign out here, and I'm going to add these two equations together. Now, if I cover up both of these, and I just gave you this system of equations, and I said, hey, solve it, then you would say, no problem, I'll just add them, because the y's will go away, just like up here, the x's went away. The only thing is, I had to do something to get the equations down to the place where something would cancel. Now what happens is when you add the 4x and the x, you get 5x. When you add these, you get 0. And when you add the right-hand side, you get 10. And then you divide by saying 10 over 5, x is equal to 2. So that's the answer, x is equal to 2. And once I have the answer, I can go back to any of these equations I want to find the correct answer. So for instance, I can go up here, and I can say, I'm going to use x plus y is 10. X plus y is equal to 10. But now I know that x is equal to 2, so 2 plus y is equal to 10. So y is equal to 8. So the answer, 2, 8. The solution. So again, this is kind of the prototype of all of the different solving by addition, solving systems of equations by addition. This is the kind of the prototype of how we're going to do all of them. What you do is you write your system down and you ask yourself, okay, if I add these together, am I going to get a variable that cancels? If I do, like up here, then you just go ahead and do it and you continue. But if you don't, then you need to multiply one of these equations by something to make it so that the next version of the equation does have something that will cancel. Now in this case, I multiplied by -1 because I just like the fact that I had y's here, and then it makes it easy to cancel it. But I have other options. I could multiply this equation, for instance, the bottom one. I can multiply it by -1. That will turn it into a -y, and then I could add it, and I would get exactly the same answer. You just have to go through it yourself to show yourself and prove to yourself that you actually would. But you have options. So in this case, I chose to multiply this by -1, and then you have two new versions of the same system of equations. But this version makes it so that when you add them, the y's drop away. And so on the left-hand side, you have x, and on the right-hand side, you have 2, and then you go and you find the other value. All right, so our next system of equations is 3x minus 2y equals -2. And right underneath it, I'll say x plus 3y is equal to 14. Now you might notice a lot of these systems of equations are ones that we've solved before. It's okay, we solved them before by graphing or whatever, we're just doing a different method. So the first thing you do is you line them up, x's, y's, numbers, and you say, okay, if I add these together, will these cancel? No, they won't. If I add these together, will they cancel? No, they won't. So I have to do something. So instead of messing around with what you've already written, what I want you to do is write both equations again. And you can mess around with that version. I don't want you to scribbling over what you've written down. It just makes it hard. So 3x minus 2y is equal to negative 2. And I'll rewrite it again. X plus 3y is equal to positive 14. Now I have to start thinking about what do I want to do. Okay, well I have a 3x and I have an x, and I have a 2y and I have a 3y. So this makes it hard. I can't cancel y's very easily. I will get to problems later where you can do that. But I know that I can cancel x's very easily, because if I multiply this second equation, what would I have to, let me phrase it a different way. What would I have to multiply this second equation by so that when I add it to this equation, I get a cancellation? I can multiply this by negative 3, because that will make negative 3x, and then it will cancel with this, right? So let me go through the solution that way, and then we'll talk about the other thing. We'll talk about how you could do it with the y's, and we'll do some problems like that later. Now what I want you to do is I want you to rewrite the system every time you do any modifications to it. So the top set of equations, top equation, we didn't change it at all. Minus 2y is negative 2. But the bottom equation, negative 3 times x is negative 3x. Negative 3 times positive 3 is going to give you negative 9y. And then negative 3 times the 14 is going to give you negative 42. So negative 3 times this, negative 3 times this, negative 3 times this. You have to do it to every term so that the second equation remains balanced. And now that you can see that, hey, if I add these, I'm going to get that cancellation, then you can add them together. Now when you add this, you get 0. When you add negative 2 plus a negative 9, you get negative 11y. And when you add negative 2 and negative 42, you get negative 44y. So then y is going to be negative 44 over negative 11. So then y is going to be equal to positive 4. Negative divided by negative is positive, so you get a 4. That's the value of y. And then, of course, to find the value of x, you have choices. You can plug it into any one of these original equations you want. It doesn't really matter what. So let's just go up here, and we'll just plug it into this equation here. X plus 3y is 14. X plus 3y is 14. So x plus 3 times y, but now we know y is 4, is 14. And then we'll have x plus 12 is 14. And then we'll have x equals, when we subtract it, we'll just get a 2. Right? So then the answer to the solution of the system of equations, the solution is x comma y, 2 comma 4. This is the intersection point of these lines. If you were to graph these lines, they'll intersect at the point 2 comma 4. And actually, to be 100% honest with you, solving by addition is actually easier than substitution. With substitution, you have to solve for something, move it over, substitute in, get something, move it in, up, and there's just a lot of ways to get confused. Here, it's actually more of a vertical thing. You just kind of work your way down the page. Now, I do have one more problem I want to work, but I want to take, since we just worked this one, I want to take a second to explain to you why I'm kind of forcing you, or suggesting to you, to do it the way I'm doing it here. What I mean by is, I've written the first set of equations, and then whenever I modify the second equation, I rewrote both equations again. I didn't do anything to the top equation, but I rewrote it again so that I can show that I'm multiplying the second equation by negative 3. I'm doing that, obviously, so I can cancel. Then I rewrite it again, so I write the top equation again, unmodified, and then I modify that second equation. Okay, a lot of students are not going to want to do that. They're not going to want to rewrite the top equation over and over again. But here's the thing. Right now, these equations are set up so that you only have to multiply one of the equations by something. All I had to do was multiply the second equation by negative 3. So I never had to touch the first equation. But that was kind of on purpose. I'm making these first problems a little bit easier so that you don't have to do too many things at once. But if you look, what if I had this different? What if I, just cover this up for a second. What if it was just this? How could I multiply this top equation by anything to give me a 3 to cancel with this? I mean, anything I multiply this equation by, this top equation by, if I wanted to cancel y's, for instance, how would I do it? If I multiply by 1 or by 2, it's going to give you a negative 2y. If I multiply by 3, it'll give me negative 6y. None of those will cancel with this. And then if I look at this equation and say, well, let me try this. What do I multiply this y to cancel here? I can't really multiply this by anything, by a whole number anyway, that's going to cancel with -2. So you see, these are easy. I could just pick something and multiply by the x and it cancels. But if you have numbers like these, you can't just multiply one of the equations by something. And I'll just give you a preview. We're not going to do this just yet, but here's how you would handle it. If I had something like this and I had to cancel the y's, I would multiply the top equation by 3. But I'd multiply the bottom equation separately by 2. Because on the top, if I multiply by 3, -2 times 3, that'll give me -6y on the top. And then on the bottom, if I multiply the bottom equation by 2, it'll give me +6y on the bottom. So then I'd have -6y, +6y, then I could cancel them. So right now, for all of these equations that I'm giving you, you only have to mess around with one equation to get the cancellation that you want. But later down the line, you're actually going to have to multiply both equations by something to get any kind of cancellation. So I'm getting you in the habit of writing the whole system over and over again, because if I had to multiply the top equation by something and then the bottom equation also by something, then I would be rewriting the whole thing and I'd be showing it as I go here. So to get the habits there, I want you, even if you only mess around and change with one of these equations, I want you to write the whole system over and over again, even though it's a little more writing. And I'm sorry, and it's more work to write things down, but it's going to lead to less errors. And I can promise you that because I've had lots of errors on my own work, and a lot of it is because I can't keep track of what I'm doing. So let's take a look at the next problem to do one more solution here. 6x plus 5 times y is -2. And then I have 2x plus 3 times y is 6. So the first thing you ask yourself is, can I just add these just the way they are? 6 plus 2, that's not going to cancel. 5 plus 3, that's not going to cancel. So none of the variables cancel. So obviously it's not going to work. So then you have to go and rewrite the system again. I know you don't want to do this, but I want you to do this. You're just going to have to trust me, because when we get to the more complicated problems, you're going to be multiplying both of these equations by different numbers to get cancellations. And then it's going to be important to show what you're doing. So here I see that I have 3 and 5 are hard. I can't multiply 5 times something that's going to cancel with 3, and I can't multiply 3 times something that's going to cancel and give me 5. But I do know that if I just multiply the bottom equation by -3, that will give me -6x, which will cancel with that one. Again, I chose this system, so I only have to mess around with one set of equations, or with one equation, I should say. So draw a little squiggly line under it. Then I rewrite the whole system again. 6x, 5y, -2. Here, -6x. Here, -9y. -3, +6 is -18. All right, -18. Now I can put my plus sign. Now I can draw my line and actually add them. So the 6x's go away. 6x and -6x go away. And then you have 5 plus a -9. So you should remember that that's -4y. And then -2, and you add it to -18, you get -20. So y is -20 over -4. So y is equal to +5. +5 is the answer. So then I can choose to put the y value into either one of these equations. It doesn't really matter. So I'm going to choose to put it into, actually let me switch colors. I'm going to put it into this one here. So let's go over here. 2x plus 3y. 2x plus 3y equals 6. So 2 times x plus 3 times y, but now I know y is 5, equals 6. So 2x plus 15 is equal to 6. So 2x subtract 15 means I have to subtract 15 right there. So what I'm going to get is -9. So then x, when I divide by 2, is -9/2. And so the solution is x comma y, which is -9/2 comma 5. All right, -9/2 comma 5. All right, so I'm going to do a little quick review of this section. Basically what you're going to do for any time you solve systems of equations by addition is you're going to line them up in standard form. If your equations are given to you with terms all over the place and not cleaned up, then bring it all together so that you have the x's and the y's on the left and you have the numbers on the right, and you line them up vertically. And then you ask yourself, can I add them? And if you can get a cancellation of 0, then you just proceed. But if not, then you have to pick one of the equations to multiply by something, which will not change the equation, but it'll change the way it looks, right? In this case, I multiply by -3 to get a cancellation here. In all of the other equations, I multiply by one of the equations by something to give me a cancellation. But just as a preview to you, later down the road, I'm going to give you equations that you cannot just work with one. I might multiply this equation by -3, and then I might have to multiply the top equation by something else in order to get a cancellation. So for instance, if I got rid of the x's here, in another problem down the road, if I needed to cancel these, I might have to multiply this by -5, and then I would have to multiply this by +3. Then I would get 15 on the top and -15 on the bottom in terms of y, and then I could cancel them. Of course, I'd have to multiply the whole equation by those numbers, but you see the idea here. So anyway, in this case, we only have to work with one equation. We get a new modified version. This equation is a modified form of the original one that allows us to cancel when we add them. And then we solve for y, plug in and solve for x. Now this whole process of, oh, let me just add everything on the left, add everything on the right, we spent a lot of time in the beginning talking about why you can do that. Because in algebra books, they just tell you, oh yeah, just add the left, add the right. But where it comes from is the fact that for an equation, I can add anything I want to the left and the right-hand side. So if you look at it in a different form, you can say, I'm going to start with this equation, I'm going to add this to the left and to the right, so it's unchanged. But on the right, I will substitute in for what's on the right-hand side. That is the genesis of why I can add the left-hand side to the left and the right-hand side to the right. It's because really you're adding the same thing to both sides. These two things are the same thing because they're joined by an equal sign. That's where it comes from. But when you do the addition, you have to make sure that you have a cancellation somewhere. And that's what allows you to do the simplification and the solving. And if you don't have a cancellation in variables, then you just multiply one of the equations so that you do then have a cancellation in variables. That's how to solve systems of equations by addition in a nutshell. Follow me on to the next lesson. We're going to get a lot more practice, but all of these problems will be done the exact same way as what I've outlined here. So make sure you can solve every one of these yourself. Follow me on to the next one, and we will get more practice.